Don't forget to subscribe and ring that bell.
And it's all come down to this. The final question for the 2015 final AP Calculus AB exam. Let's do this. Be still my heart. We don't get a calculator, but we do get to use our brains, and that's all we really need to know. So, let's destroy this problem and go have a drink, shall we? Problem 6 reads, consider the curve given by the equation y cubed minus xy equals 2. It can be shown that dy dx equals y over 3y squared minus x. Okay, thanks for the information. 3a says write an equation for the tangent line to the curve at the point -1, 1, easy. Easy. First of all, bing, 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 when they say to write there you go, write an equation of a line, we are thinking y minus y1 equals m times x minus x1. And when we think that, we need an x coordinate and a y coordinate, and then we need the slope, which is pretty much just the derivative. They give us all this, people. Here's our x, -1. Here's our y. And oh, by the way, our derivative is this, y over 3y squared minus x. And all I've got to do is plug in my y1 and my x1 into that derivative to figure it out. I mean, it's simple. Y minus 1 equals, we'll wait for the slope for right now, x minus -1. When I subtract a negative, it's like a super plus, kids. So look at my slope is the same thing as my derivative. Y over 3y squared minus x. My y value is 1 over 3 times my y is 1 squared minus my x, which is -1. I mean, 1 over 1 squared is 1 times 3. It's 3. Subtract a -1 plus 1. My slope is 1/4. Kids, you're welcome. That was the easiest start to any problem that we could have had for number 6. Don't try and get y alone. Don't distribute the 1/4 and then add 1. You can, but why risk going fast and making a mistake when we've just boxed in? That is point slope equation of a line right there. That is good. Okay, here's where it gets real, kids. 6 has only 3 parts, A, B, and C. And one of these is going to be algebra heavy, and it's probably going to be B. Find all coordinates, find the coordinates of all points on the curve at which the tangent line to the curve at that point is vertical. In order to have a tangent line that is vertical, my derivative needs to be undefined. Not 0. 0 would be horizontal. Vertical is undefined. So in order to have my derivative, which is this right here, y over 3y squared minus x, be undefined, we should know one basic rule about fractions. The bottom, or the denominator, cannot be 0, because if the bottom, if the bottom is 0, the whole fraction is undefined. So since that's what we want, we are going to take 3y squared minus x and set it equal to 0. Because again, if the bottom's 0, that's how I get this to be undefined. All right? And, I really can't do anything yet. But what I can do here, why don't I just add x to both sides? So I know when x equals 3y squared, whatever y is, when this x right here is 3y squared, I'll end up with 3y squared minus x, which is 3y squared. Okay, that's really all I can do at this point. They want coordinates. Okay? When it comes to slope, I always go to the derivative. When it comes to coordinates, I always go to the original equation. Okay? So if my original equation is y cubed minus xy equals 2, and anywhere there's an x, I'm going to substitute in a 3y squared. All right, yeah. Y cubed minus 3y squared, that's x, times y equals 2. All right, well, I can combine, well, before I combine, why don't I at least multiply these two together? So I've got y cubed minus 3y cubed equals 2. Okay, now we're going someplace. Now I can combine 1y cubed minus 3y cubed. That's going to give me negative 2y cubed equals 2. Now let's keep going. Divide by negative 2. Y cubed equals negative 1. And now, because I'm fancy, I'm going to take the cubed root of both sides. And I know y would equal negative 1. Okay? Y equals negative 1. Again, I have the y coordinate. I don't have the x coordinate, do I? Well, what is the x coordinate again? X is 3y squared, isn't it? Oh, kids, it just writes itself. X is 3y squared. Y is negative 1. 3 times negative 1 squared, that becomes positive 1, which becomes a positive 3. So, I really have the coordinate 3, negative 1. There you go. That would make this undefined, meaning it would be a vertical tangent line. And by this, I mean the derivative. Now, some of you might say, this guy, I thought in order to get a coordinate, like you got the y, but in order to get the x coordinate, shouldn't I go back to the original equation? I mean, I suppose I can throw this y of negative 1 into here. Let's see if that would work too, into this y. Because this is my original, okay? I remember I circled this, I said original coordinates. We always go back to the original equation. Let's just double check that just to make sure. If y is negative 1, okay, I have y cubed, which is negative 1 cubed, minus x times y, which is negative 1, equals 2. Negative 1 cubed is negative 1. Y was negative 1. I wrote negative y there. Negative 1 times a negative x would be a positive x equals 2. And look at us go. Add 1 to both sides, and x equals 3. So it did work. Okay? It did work. It's because we're smart, children. We're smart. I almost don't want to do this problem. Not because there's something wrong with it, because when I do this problem, we're going to be done. And when we're done, that makes me sad. It makes me sad when we're done doing math. But you know what? Don't be sad because it's over. Smile because it happened. How lucky are we to have something so incredibly difficult to say goodbye to? You can use that quote. I love that quote. Anyways, 6c tells us, evaluate the second derivative, d2y over dx2, the second derivative, at the point on the curve where x is -1 and y is +1. I'm not going to get ahead of myself. Let's do this. And then there's going to be something that we already did that we're going to pull back in that's going to save us work. All right. First off, let's take a look at the first derivative. And I need to take the derivative of the first derivative to get the second derivative. Okay. So this is a fraction. And I haven't done a lot of this. It's low d high minus high d low. Draw a line and square below. Okay, so it is low 3y squared minus x. Low d high means the derivative of the high. That's a y, so it's just 1, but it's because we're taking the derivative of a y, we got to write dy dx. So it's 1 dy dx. Low d high minus high, just as it is, times the derivative of below, d low. Okay, so this is going to be 6y, but since it's the derivative of a y term, we write dy dx next to it, minus the derivative of x, which is just 1. I draw this line, and I square the entire below here. 3y squared minus x squared. This is the second derivative. I'm going to put parentheses around this dy dx here. I want this at the point every x is going to be -1. Every y is going to be a +1. Well, what do I do, friends, with dy dx? Guess what? Dy dx is this. Okay? I can substitute that back in. I can be fancy. And I could put this whole fraction in here. But I also want this at the point where x is -1 and y is 1. Now, you remember when I first started this problem, I started to talk about, we've done some work already on this. If I go back to part A, I've already figured out the derivative at the point -1, 1. We've done this already. It's 1/4. That was the slope here. So I've already got the first derivative at this point. It's just 1/4. The first derivative at the point -1, 1 is 1/4. So I'm going to put a 1/4 in to both of these dy dx's. All right? Let's just plug in some numbers and do some simple basic algebra. We have 3 times my y, which is 1, squared, minus my x, which is -1, times dy dx, which is 1/4. The derivative, the first derivative at this point is 1/4. Minus, okay, my y. We got to subtract this whole thing. My y, which is 1, times 6 times y, which is 1, times dy dx, which is 1/4, minus 1, all over 3 times y, which is 1 squared, minus x, which is -1, this whole thing squared. So let's make sure we got everything. My x's here, okay, and here, okay. My y's here, and here, and here, and here, okay. And my dy dx's. All right. Let's do some algebra, kids. We're ready. We've worked hard. We're to the point where we're ready to do this. Okay, let's get this out of here. Boop. 1 squared is 1 times 3. Okay, that's 3. Subtract the negative 1 is like plus. 3 plus 1 is 4. 4 times a fourth is 1. This whole thing is 1 minus. Okay, anything times 1 is itself, so I can pretty much get rid of that. 6 times 1 is 6. 6 times a fourth is 6 fourths, which is the same thing as 3 halves. But then we got to subtract 1. 3 halves minus 1, or 2 halves, is 1 half. All right? All over. We already did, up here we came up with 4. This is the same thing. It's going to be 4, but this time we're squaring it. 4 squared is 16. We don't have a calculator. I mean, really, we don't need a calculator. All right? 1 minus a half is a half over 16. And if I multiply the top and bottom by 1 over 16, I get 1 over 32. And that, my friends, is the end. And I would like to say thank you to all you guys that have put comments, liked, watched this, maybe told someone else about it. I mean, I'm just a math teacher, and this past month, there were 16,000 views on my videos from about 3,000 different people. That's remarkable, considering I'm not putting up Five Nights at Freddy's. I'm not, recording, gaming. I'm just doing calculus, and it's growing. It's growing every year, especially right before the AP Calculus AB exam. That's my niche right there. So thank all you guys for the kind words. You guys are going to do awesome on the exam. I can't wait. If you do well, I mean, come back, make a comment on one of the videos being like, hey, Visca, I scored this. I'd like to know. I'd like to know how you guys do. Get some sleep before the exam. Eat decent breakfast. Nothing. Don't eat too much fiber. You don't want to get the runs in the middle of your AP Calculus AP exam. But just be ready for it. You got this. You're prepared. Good luck.
Don't forget to subscribe and ring that bell.